Hi everyone, I am Ankita and today we are break down one of the most powerful ideas in cryptocurrency in Web3, zero knowledge proof. So in this video we will cover what zero knowledge proof really mean, how they actually work step by step, and the simple example and where they are used in blockchain today. So let's start from the very beginning. What is zero knowledge even mean? What is the zero knowledge proof? A zero knowledge proof is cryptographic way to prove that statement is true without revealing any extra information. There are the two people involved, the prover who wants to prove they know something and the verifier who checks it the claim is true. The magic here is the verifier get convinced but never learn how or why the statement is true. In the zero knowledge proof there is always be the two person, the one is the prover and one is the verifier. The prover proves that what I know that the password, I know that details, but verifiers only verify, they don't actually show that the password and all the details. Without showing them they verify. So how that work? Like zero knowledge proof let one person call the prover and the convince another person. The prover convince the another person, the verifier, that a statement is true without revealing any extra information beyond the fact that is true. Okay, so prover will not be any disclaimer or disclose or shown any password or any personal information to the verifier. Then also the verifier can verify. That is like a zero knowledge proof. And you think about that, that is like a magic and what? Why they are prover proving and how the verifier can verify this. So how that work? We can see. We understand with the one example. There is like a real life analogy, the magic door example, a very known example of the zero knowledge proof. Here's the Victor play role of verifier and the Peggy is the prover. Let's that image a cave shaped like a circle with the two entrance. Here's the two entrance. The one is A and the one is B. And the magic door middle and the only opens when you know the secret password of that magic door. You the prover, means the Peggy is the prover, claim to know the password. Peggy said that I know the password of that magic door. And Victor, as a verifier, they want to be sure the Peggy know the password, but Peggy don't want to tell the password to the Victor. And then also how they know about Peggy knows the password. So the Peggy enters through a random path, like A path. Peggy enters from the path A, and Victor wait outside and shout them come from the B. If she goes the path A and she want to be out from path B, then she have to know the password of that magic door. If Peggy really know the password, you open the door and come out from the B. If you don't, then you will stuck here because the Victor see from here that Peggy goes from this, and if they're out from this, then she knows the password. If this trick repeat the same time, if the one time prover enter the path from A and the Victor also says the come from path A, then the same path, so she can come from this. But now she enter from the A and Victor wants to be come out from the path B, then she has to be know the password secret code for this door. So this all of that things happen repeat multiple times. She will be doing every time properly, then the Victor can be mathematically sure that she know the secret without even saying it. Means like Peggy don't say the password, but she comes like proper way, so she know the secret. Like this is type of ZKP work. So Victor is convinced, she learned nothing else. Means she don't know he don't know the password, but she knows, Peggy knows. So Victor convinced, and that ZKP work like tick mark. It's okay, done. In ZKP there is a three key properties in ZKP. So every zero knowledge proof follows this golden rules. Like in ZKP this is three golden rules. So first is completeness. If the statement is true, the prover can convince the verifier. Like here the statement is true, then the Peggy convince the Victor that I know the password. But soundness, if the statement is false, a liar can't fool the verifier. If Peggy don't know the password, then they come out the wrong and verifier don't agree with that she knows the password. So that soundness like that. And zero knowledge, the verifier learns nothing beyond the truth of the statement. the verifier only know she tell whatever she tells truth, but the verifier don't know the password and anything about her and the door. So here's also the like two types of ZKPs, the interactive ones, interactive versus non-interactive. So what are the difference between them? There are two main ways ZKP work: interactive and non-interactive. Interactive ZKPs. Here's the prover and verifier talk back and forth. Means like multiple times the verifier asks how that you prove, like that. Different ways. The verifier send random challenges. So they talk back and forth. So verifier send them random challenges and the prover replies each time. Prover has to be reply each time and each time is correct. Think of it as a live quiz. The verifier keeps testing the prover. Then the second one is non-interactive ZKP. Here the prover creates one single proof and send it to the verifier. No back and forth conversation, means no multiple times asking and proving challenges and all of that things. This is made possibly by something called Fiat-Shamir heuristic, which replace the interaction with cryptographic hash. From this they talk with the cryptographic hash and they replace with the interaction from there. Most modern blockchain system are non-interactive proofs because you can verify them easily on chain without any direct communication. Like here the one diagram is, we can zoom it. Okay, here's the prover and verifier. The one is the prover and the one is verifier, and they interactive with interactive zero knowledge proof process. Okay, they are interactive process. So the commitment encrypted statement. Commitment means it's like a sealing information in envelope and you can prove something that inside something exists inside without opening it. The interactive flows show multiple rounds without opening. A commitment is like a sealing information in an envelope and you prove something exists inside without opening the envelope. So here's the prover prove something, they know what are in the envelope. So they are interactive flows, the multiple rounds. Here's the interactive is the multiple one. So here's the multiple rounds done by the random challenges and the response proof, whatever they gave, like by the prover, and the verification check, the final acceptance or rejection. Means after the multiplication round, verify if the prover said he knows that inside what is inside, then it is right and the final acceptance or rejection happen. If that prover can be the proof that right, then it's acceptance, and the if we not prove properly, then the rejection also happen. Then the other one is non-interactive. What is the non-interactive? There is in the non-interactive proof means like zk-SNARK also allows everything to happen in one go, like a sending complete puzzle solution at once, like a single proof statement and verify the proof and the verify, not like multiple rounds. So how the ZK proof work step by step? Here we can understand how the ZK proof work. Let's simplify the process. A conceptual example. Here's the prover explain the statement this: I know the secret number x such that when I square it, the result is 49. Now you want to prove this to me, but without revealing x, which is 7. X is which is 7, that prover know, but verifier don't know, and I don't want to know that prover verifier know that the number. So how I can, like, without revealing, how I can explain and that secret number? So here's the what happens behind the scenes. Like, define the statement x square is equal to 49. Here's the normal statement, not like this way in the real process. Define the statements like x square is equal to 49. Prover means you. So plug in your private input x is equal to 7. Okay, the prover knows the x is equal to 7. The verifier only knows the public part 49. Using cryptographic math, you generate a proof that you know some x satisfying the equation. Okay, the verifier checks this proof using the verification algorithm that gets true and false. Whatever the answer is true or false. The verifier never learns that x is equal to 7, but 100% sure that some valid x exists and the prover knows that x. Then inside the technology, how the circuit and cryptographically work, like this process, how can work So let's go one deeper level how computer actually do this. The statement or programs like x2 is equal to 49 is converted into the arithmetic circuit, a network of additions and multiplication. The prover creates a witness. The prover creates a witness that's basically the secret input value that satisfy all constraints. Then the system runs cryptographic algorithm to compress their entire computation in a short proof, often just a few hundred bytes long. This is like proof is long bytes, then make them short byte, like few hundred bytes only. The verifier checks that proof with the minimal computation and usually just few cryptographic checks. If everything is correct, then proof verified, prover get correct and proof verified, then verifier get no, prover know that things and the proof is correct. If not, then verification fails. This is the why blockchain loves ZKP. Verify is the fast and cheap, even if proving takes more time. In the proving time is like taking more time, but the verifying is fast and cheap. And also like in the secret way. It's types of ZKP in Web3 means like now what types of ZKP we are used. There are few types, few main families of ZK proofs used today. Like first is zk-Sync. zk-Sync means zero knowledge succinct non-interactive argument of knowledge. That is zk-Sync. The word works like on like this type algorithm that you know already. Succinct proof, small size, very fast. Succinct proof, small size and very fast verification, but need trusted setup. For this zk-Sync, you need a trusted setup, but with this, you can a small size and fast verification and the proper proof you have whatever proof that is they needed. The succinct proof, मतलब proper proof. zk-STARK. zk-STARK means zero knowledge, scalable, transparent argument of knowledge. Scalable transparent argument. Here is the succinct non-interactive argument. Transparent, no trusted setup. Means here is the no need to make a trusted setup, but that is scalable and the quantum resist. But proof are larger because they are asking the many type of question, the multiple times. So there is a proof is larger. So verify the proof that also make a more time. Bulletproofs used for the range proof, like in Monero. Bulletproof used for the range proof. And Halo 2, recursive proof, no trusted setup used by project like Zcash and zkSync. That kind of project they use a Halo 2 proof. What is the real world uses in the ZKB and how that fix a big problem today. Like we all know in this video what is the ZKB and you don't give the proof and verify and all of that, but how that will be used in the real life and real world. So ZKP are not just a theory anymore. This time they are solving real problems and right now, and they are used right now also. Like in private money, send a crypto on a public chains like Ethereum, but hide who sent and how much to whom. So, like we send the crypto to Ethereum, then we all know the Ethereum public address, and with that address, we know also how much they transfer and which address they transfer. That all information we can see that. So here's the ZKP use, and Zcash does this with using zk-Sync. So transactions stay valid but completely private. No spies is watching your wallet. Means so no spies or any hackers not watching your wallet. How much they have transferred in which kind of wallet and which address. That all information is hidden, and then also the transaction is valid. So that kind of use by the Zcash and in the private money. Faster blockchain. zk-Rollups bundle thousands of transactions into one proof. That proof is posted to Ethereum, cutting fees by around 90% and boosting up to 10x. Projects like Polygon, zkEVM, and zk-Sync are leading. This is in 2025. Means like in zk-Rollups there are thousands of transactions run in like one bundle. So all the proof and all transaction run by the one chance, like one time. So this all happen transaction in bundles. So the cutting fees means like gas fees is cutting around 90%, and with the bundle of transaction they make a speed of 10x. So that kind of things happen, and with the zk-Rollups the faster blockchains. blockchain become faster. They like making a transaction in speeds, and project like Polygon, zkEVM and zk-Sync are leading here in zk-Rollups. And the third is safe ID and voting. Prove you are 18 or a real safe ID and voting. In this, I give an example. If you go for the movie, if you want to see the movie and you go for the theater, but that movie is 18 plus, so the person that asks you are 18, so you give the document of your like showing that 18. Okay, but you don't want to like show the all document like you prove for the proof to you are 18. So because that is your sensitive documents and you don't want to see another people see this. So how can be done in like zk-Sync? So prove you are 18 or real human without revealing your full identity. I don't want to my identity full identity. I don't want to see you by the any person. So in DAO, ZKB enables anonymous and fair voting, no bribery, no tracking, and total privacy. So zk-Sync check. Here's the ZKP check. The person is 18 plus. That don't tell you the any other details to the verifier. But after the checking, verifier also know yes this person is 18 plus, so he can be voting in DAO or he can be go for the movie. Then a financial checks. You can prove you qualify for the loan without showing the actual bank balance or transaction history. We all know if you want to go for the like a banking loan, any loan, if we go for the loan, and so the bank person or the manager asking us to be the like give the details of your bank, all the transaction, all the balance, what are the things you have, and how much amount you want to loan, and that all transaction, all bank balance, the bank person sees that. But you don't want to like give the all the things. So there is use of ZKP. Then AI and computational proof. Even AI developers can prove that model can run correctly without revealing entire model or dataset. I don't want to like my all model to give the someone and to prove that like model run correctly, all the information. I don't want to give them that kind of that many kind of example according to ZKP. Here the I show the many one of the most famous puzzle of the Waldo, that wearing a glasses and red and white sweater, blue jeans and pin cap. Let's say I wanted to prove to you I know where is Waldo. If you say that images, I want to prove to you where is window, but I don't want to show the location of the window. So how can I do that? They put a like big black papers on it, like they show the one square and they show the window. Then you know the yeah, I know the window, where is the window. But you also don't know where is the window because that paper is bigger than the picture. It's very bigger than the picture. Then you don't know where I put the painting and where is the window's location. So like that way also you understand the what type of ZKP works. If I don't know, then if the claim is false, then I don't convince the verifier that I know the window, where is the window. And the another one example, there is also famous example. Here is me and here's my friend, but my friend is colorblind, and I show you like two different color of circles, but my friend don't understand because he is a colorblind. So how I prove to him that is a different color without knowing that, without saying the color is. So how can I prove this? I give the two circles to my friend, and he don't understand the what is the color because of he is colorblind. So and like you do whatever, how I can that prove that I know. So first time he like show this like circle in the pink and green position like that. He asked me, is a switch or not? Means I switch this things or not? Then I say, no, you are not switching this. So pink and green same. And then another time he switches. Okay. And how that switches is behind her. So she don't know how my friend is switches. So then after switches, then he show me there is a green and pink, but I know the color. So I said her, there is, you switch this. So there is like many times they done all of that things, and after he knows he switch or not, so he also understand yes there is a two different color. Same way the ZKP work, but after he knows there is a different color, but after he like many times the switches the colors, and then he asked to her like if if this is switch or not, if this is switch or not, and the multiple times. If the prover is right, then you know the like he knows that there is a two different color and he sees that, but you don't know what is the color, because now also you are a colorblind and you don't know the color, but you understand that there is a different color so that she can understand. Like that kind of zkp works. That is like all three example, the Waldo, the K one, and the colorblind one. There is a main three example to explain how ZKP work. All the person want that their own details don't want to show the another person, or don't want to show all the details to another. So here's the ZKP proof work. So here, zero knowledge proof let you prove something is true without revealing why and what. They combine cryptography, mathematics, and the logic to create a privacy-preserving and scalable systems. If one of those technologies that sound like magic, but they are actually math, that is not magic thing. If I told you this example, you think like this is kind of magic, but this is not magic. It is a mathematical and actual math. I hope now you understand what ZK proof and how they work. In my next video, I will show you the live demo which how actually you generate and verify ZK proof using Circum and Stank.js. So make sure to subscribe to Code by Ankita and turn on the bell icon. We will dive from the theory to hands-on coding next. Thanks for watching and keep building smart.